Good morning. You should hear me and you should see the desktop by now. Does that seem correct?
Yeah, it seems fine.
Okay, great. So, thanks. Right. Okay, so today we're going to keep talking about what in Java are called objects and object-oriented programming. So, we're going to be using some more turtle examples and also something called the string objects. So, we're going to look at, see these two sections here, string objects and string methods. Okay, so we're going to keep talking about, we're using the example of a turtle and the example of strings to get across the idea of what we mean by object-oriented programming. This is the way we write programs in Java. It's one of the key ideas in Java programming, and it's actually the key idea in most modern programming languages. If you hear about the other languages that are in use these days, Python and JavaScript and C Sharp and C++, all of them share with Java this idea of being being an object-oriented programming language. So this is the key idea for what we think of as modern programming languages. Okay, so there's a new reading assignment. The last couple sections of this chapter we're working in, uh, the last section in this chapter is just a summary of the chapter, and it's a nice summary. Okay, so this last section, you notice how it lists a bunch of words. Be good idea for you to keep looking at those words and trying to make sure you understand, you remember the meaning of them. Today we'll talk a lot about these words, but these are the key is the key vocabulary that we're going to be using for the rest of the semester. And as a programmer, we use these words all the time. These are just really important words. They're really fundamental to understanding programming. So that section's kind of nice because it's a good summary. Okay. And there's also some homework problems for you to look at, some practice problems. So this page at the end of the chapter has a lot of these mixed up code problems where you have to put the code in the proper order by dragging onto the right. So those are really good problems to do, give you a sense of how it's a good way to get started with how do you write your own code. Here you don't have to write the lines, you just have to get them in the right order. So that's a good way to get a feel for how programs get put together. So you have to read the line, you have to read the problem, read the lines, and figure out what order they should be in to make the answer correct. Okay, so do those, and then there's other problems where you actually have to write the. Oh, no, I'm sorry, not that one. The other set of problems are ones where you're more writing the code yourself. See, they give you a box, okay? And there's a bunch of problems on this page. These are much harder, and I asked you to do as practice the second, third, and fourth ones, okay? Actually, it's they've numbered these things kind of weird. Let's see. Yeah, this one says three, but it says two here. This is the second one. Okay, so the second, third, and fourth ones. Okay, those are good ones. I thought those were good ones to work on. Okay, okay. So practice working with code yourself. Okay, because you can work with the code. Yeah, like here, actually, the problem here is you have to get rid of lots of compiler error messages. So they keep see. Actually, you're not even going to write any code, but you'll just keep trying to get rid of all the errors that are in this code. So that's a good thing to be practiced with. Try to get rid of all the little errors that they snuck into the code in different places. Okay, so yeah, you as practice, read an error message, figure out what they did, what's going wrong, what's been typed wrong in these lines of code up here. Okay, all right. So a little bit more reading and some practice problems to work on. And if you have questions about them, like if one of those practice problems doesn't make sense to you, or if you can't figure out how to get it working, you can either send me an email or come to office hours. I have office hours this afternoon, or arrange a Zoom meeting. Okay. All right. So now let's do some more example of working with the turtle graphics. Okay. Now this was the code that we worked on the other day. You know, and what we want to do today is go back through code examples like this, but we're going to draw a picture that's going to give us a sense of how we're supposed to think about this code. Okay, now the Java visualizer draws pictures for us, but we can't run this code in the Java visualizer. So we're going to draw the picture ourselves, which is good practice. We're going to draw the picture ourselves without using the Java visualizer. When we do string examples, we can use the Java visualizer to help us draw pictures, but not for the turtle examples. So what I'm going to do is start up Dr. Java. I'm going to type the code into Dr. Java. Okay. Now, there's two ways I can do this. This is the code that we did in class the other day. I can download this code. So if I right click on this page, I can say save as, and I'm going to save it to my desktop. Okay. So I just downloaded that code to my desktop. So now I can pull it into Dr. Java and I could compile it. Okay. And then, oh, let me think. I think if I remember right, we don't need this line of code here. You need it on their website, but it doesn't need to be used. It doesn't need to be in Dr. Java. And that's the one I think that was giving the warning. So compile it. See, no, there's no warning. That last line of code is needed when this code runs on their website, but it's not needed when it runs in Dr. Java. Okay, so then I can run it. Okay, so that code drew that picture. That was the turtle code. Okay, now there's another way. I can change the code up here and keep work and redraw this picture. If I make a change up here, like this is the turtle called Yertle, and this was the second turtle. Okay. Okay. If I go here and add a little code that make the second turtle, tell him to go forward again. Okay. If I compile this, when I compile it, the picture will disappear. I really can't update that picture. I have to draw a new one. So if I compile it, see the picture disappeared, and then I can run it and see he now went forward one more time. Okay. Now, here's a more interactive way to play with this. So I'm going to close that picture and I'm going to go to this other this window down here. This says interactions window. I can type lines of code from up here down here directly. So I can say world, I'm going to abbreviate it, W equals new world. And I'll make a 300 by 300 world. And I hit enter. See, the world pops up. I created a world object. This word here means make a new object. I created a world object and I gave it some information. That information specified how big the world should be. It's 300 units across by 300 units tall. And then the Java system went and created that world. Okay. Now I can add a turtle to it. So I'm going to create a turtle object. I'll call him T1, so I type less. Turtle 1 is a new, now I'm creating a turtle object. I created a world object, now I'm creating a turtle object, and I need to tell the turtle what world it lives in. Okay, so I need to specify that this turtle, this new turtle object, lives in world W. Okay, see, then he shows up now. Then now I can call a method on this turtle. So I can say turtle1 dot, we say I'm calling a method on the turtle. Okay, and I'm going to tell the turtle to turn right. Okay, so now that method didn't need any information to it. It just says turn right. That means turn 90 degrees. Yeah, see, this method had what we call parameters. It said how big the world should be. This method needed a parameter. If I created two worlds, and we'll do that in a second, I can create another world. I can put a turtle in one world or put a turtle in a different world. So I could have two of these world windows. And when I create a turtle, I could say which world it belongs in. So that's a parameter. Oh, notice how this is world W equals new world. Now this is what we're going to draw pictures to see why the word world appears twice there. This is a world variable. It's for us to be able to talk about the world. So we can use it, for example, over here. This is the world object. It's actually this thing over here. The variable and the object are not the same thing. And in a minute, we'll draw a picture to see what we mean by that. So, for example, you are not your name. You have a name and you're a person. People use your name to refer to you, but the name is not you. If you have been born in a jungle with and been you've been raised by lions, you might not have a name, but you still exist. Okay, you know, uh, you don't actually have to. Most animals exist, but they don't have names. Okay, here, that's an important idea in science. This is the thing. This is just a name for that thing. Okay. W isn't the world. W is a name for the world. The world is what we call an object. The new creates the object. Same over here. This is just a name we use for the turtle. So we can say, hey, you to it, essentially. Hey, you, turn right. Okay. This message is actually sent to the turtle object. Okay. So this creates the turtle object and then gives it this name, and we can use the name to refer to that turtle. Okay. Now, here's something funny I can do. Turtle T2 equals T1. Notice I didn't create another turtle. What I did there is I gave this turtle another name. So for example, I say T2 dot forward. See, it's that same turtle. That turtle now has two names. T1 dot turn left. See, I'm alternating using the different names. So I've got one turtle object and two turtle names. So see, this use of the word turtle creates a variable, which is a name for a turtle object. And this one just said, this one's another name for that object. Now let's draw a picture of here's how we're supposed to think about this. So I'm going to use a paint program to draw a picture. Okay. This is Java's memory. I'm going to draw a picture. I'm going to draw a picture very similar to the way the Java visualizer does it. So on the left, I'm going to have what in the visualizer is called the frames. The frame. And on the right, I have the object. The frame is where the names go. The objects themselves go over here. So in my I have to scrunch all these windows I have to kind of keep going back and forth between windows now. So hopefully it won't get too, you have to keep concentrating on the different things going on. Okay. The code is typed into this window here. The results show up in this window here, and I want to draw a picture of what I've done over in this window here. Okay. I created my first line of code, created a world variable. So I think of that like if it was in the Java visualizer, there'd be a little box. Oh, not that. There'd be a little box over here. This is a world variable. Okay, and this world variable has the name W. Okay, now this part over here created a world object. So over here, we draw a box that's a world object. Now, what's in that box is information about the world. So this is now a world object. So this is a world variable, a name for that object. And what we're going to do is we think of it as there being an arrow pointing from one to the other. Okay. So actually, I think it looks better if I just draw the arrow real simply. Here's a simpler way to draw arrow. I've got an arrow pointing, that variable points to that object. This object holds information. Now it's hard for us, the world, well, in this case, the object holds, it's pretty, yeah, it holds those two numbers that tell the world how big to draw itself. So inside this world object are two numbers, the number 300 for its height and the number 300 for its width. And those numbers are used by Java to know how big to draw that world. Okay. Now this is what objects are. Objects are things that hold data, that hold information. Okay. A world object knows how big it is. Okay. Now, then the next line of code, this one here, does essentially, now notice that this line of code did three things: create the world variable, create the world object, and make the variable point at the object. This is going to create a turtle variable. So I'll have another variable over here. I have a variable. We draw a variable as a box because variables hold things. Later on, we'll see that the box can hold numbers. They can hold these things that we call references. This thing here, this arrow is called a reference because that name refers to that object. Later on, we'll have variables that hold numbers. And right now, our variables hold references. Okay, so over here, I've got a turtle reference variable, a turtle variable called T1. And that's the left-hand side here. Then the right-hand side is going to create the turtle object. So then I'm going to get a box over here we think of as the turtle object, where the data is for the turtle. Okay, so then this is a turtle object. See, that's why the word turtle showed up twice on this line. The turtle name, the variable, and the turtle object. Okay. Okay. Now this turtle is told that it's in W. So there's a connection between these two turtles. We won't put that in the picture, but this turtle knows that he's in that world object. So he actually becomes part of the data of this world object. Okay, so this world object and this turtle are linked together now. Okay, then there's going to be an arrow that says this turtle is a reference to that turtle object. Now remember when the data in the turtle object are things like, go over here, what coordinate is the turtle sitting at? Okay, so those are X and Y coordinates. So the turtle has got in him an X coordinate, okay, and he's got in him a Y coordinate, and he's also got in him what direction he's pointing at, a compass direction. I'll call it the heading. Okay, so initially the turtle is at, initially the turtle has got X equal to 0. He's at the center of the square. That's X equals 0. He's got Y equal to 0. And his heading, you can think of his heading as various ways. He's headed north initially. See, he was put here pointing up that way. Or you can think of that as an angle, where if north is angle 0, you can think of that as angle 0. And then, for example, if I make him turn right, I can think of that as angle 90. 90 degrees clockwise from north. Okay. So this data is in the turtle. But then then we told the turtle to turn right. Well, what turning right did was change that number there from 0 to 90. Okay, so he was first created, when he's created here, that data there would be 0 because his heading was be pointing north. But then when you send him, oh, and we also, we made him move forward. When we made him move forward, we made the x coordinate 100. So his x coordinate is I can update the x coordinate by erasing what was in there. His x coordinate will be updated to 100. Okay, that was the forward command. So he's created, turn right makes him turn, his heading changes to 90. Forward made him change his location to x is 100, y equals 0. But this intermediate line, what it did was the following. The left-hand side of this looks just like the left-hand side of this. So the left-hand side of this does the same thing it did before. It creates a new turtle variable. So it creates a turtle variable. Okay. But that turtle variable is called T2 now instead of T1. So it creates a turtle variable T2. And then it says the value of this turtle variable is the same as this turtle variable. But this turtle variable is a reference to that turtle object. So that makes, this is how we think of it, and this is how the Java visualizer would draw it if we could do it. It puts an arrow from there to there. We have two references to that single turtle object. We have two turtle variables, but only one turtle object. So now we can use either name to change the data in here. So I can go back over here now, and I can use either one of the names. I'll use T2 this time. T2 to, okay, here's the turtle. Okay. I can make him, if I make him move forward again, notice forward moves him in the direction he's heading. So forward here moved him to the right because he had turned looking due east. So forward made him move east. Now he's heading back north. So now forward makes him move north. Okay. So notice that you can't say what forward means move forward, but you don't know what direction that is. Okay. The turtle's remembering his direction. So whatever his direction is, that's what governs what his forward command means. Okay, so now he's at this location. He's gone over 100, up 100. So if we go over here and update this picture, now we've changed the y value. That last turtle command changed the y value to 100. Now if this is 0, 0, he's over 100, up 100. So now that last turtle command changed the data inside the turtle. Okay, so now the turtle is at location 100, 100, and its heading is 9. I forgot to, when I did the turn left, his heading should have changed too. So when I did the turn left, I should have said, oh, that updated his heading to be 0. He's heading north. Okay. Okay. So this created the turtle. When the turtle's created, he's at location 0, 0, and he's headed north. Turn right made him head east. Okay. Then forward made him move east. Then this made him face north. Then this made him move north. Okay. So now he's at location 100, 100, and his heading is heading north. Okay. Okay. If I make him turn left now, I'll use T1 dot turn left. Okay. If he's here and he turns left, he'll be heading this way, which we'll think of as negative 90 degrees. Okay. That's 90 degrees. He's heading west, and we'll think of that as negative 90 degrees because that's 90 degrees counterclockwise. See? So this would be over here. His heading would be, now we'll think of his heading as negative 90 degrees, which is 90 degrees counterclockwise. Positive angles are clockwise, negative angles we'll think of as counterclockwise. Okay, not everybody agrees with that. Sometimes people do it the other way around. Like in calculus classes, actually, counterclockwise is positive angle and clockwise is negative angles. Usually in a trigonometry class, it's the opposite. So either way it can be used. You can think of north as being, in most trigonometry classes, east is the zero direction. East is the zero angle. I actually forget, the turtle does use angles, and I'm actually trying to remember which way the turtle does it. I think the turtle does it the way we're doing here. I think he stores the angles this way, but I don't remember for sure. Okay, so that's why we use things like forward, left. So that helps us not have to remember which way the turtle is storing angles. Okay, so it's real convenient to think of just turn left, turn right. You can also make the turtle turn it at a 45-degree angle. Okay, so if you do T1 dot turn, then you can say with an angle, turn 45 degrees. Okay, well, well, misspelled it. Oh, notice what happens when you misspell things. See, there is no trun command. Okay, so I can't tell the turtle to trun. So I misspelled turn, so I got an error message. There is no trun in turtle, but there is a turn in turtle. Okay. Okay. Oh, and 45 degrees was, see, he turned clockwise. He was facing due west, and I said turn 45. He rotated clockwise. So positive means clockwise here. That's opposite of what it is in most trigonometry classes. Positive means counterclockwise in most trigonometry classes or in calculus class. Okay. So then if I notice now over here, if I say T2 dot turn negative 45, that's the same turtle. See, now he's right back where he was. So turn negative 45, turn 45. See, I'm talking to the same turtle all the time, but I can change the name because I've got two names, the way we'd say it, we have two reference variables to this turtle object. So we can use either turtle reference variable to call methods on the turtle object. Whenever we call a method on the turtle object, we're updating the data in the turtle object, and then that data gets used to draw the turtle. Java uses the data in the turtle object to draw the turtle over here. Okay. Now, these kind of pictures help us think about this because, for example, otherwise here, it's real hard to know why I can send commands to T1 or T2 and they make the same turtle move. It's not so obvious why T1 and T2 over here would make the same turtle move. You think if I have a T1 and T2, I'd have two different turtles. You can keep looking back at the code and think real hard about what happened here. Here's where we have the two names for the same turtle, or you can just keep a picture like this. And if you keep a picture like this, it's clear that T1 and T2 are references to the same turtle. If I want another turtle in my picture, T3, oh, okay, well, if I want to create a new turtle, I can't just say T3 equals new turtle because there is no T3 name yet. Oh, turtle in world W. Okay, this won't work. That'll give me an error message because I never said to Java, I'm creating a new name for a turtle. So I have to create both a new name for the turtle and a new turtle. So this creates a new turtle, and this creates a new name for the turtle. Okay, let me bring up the turtle picture so you'll see that turtle appear. There he is. And I can make him move forward. T3 dot forward 50. So I sent data to him. Over here in this picture, I created and it's real important to keep the picture up to date, keep track of this. I created the turtle variable, the reference variable. So it's a turtle reference variable. I gave the name to the reference variable T3, and I actually created another turtle object this time. So I created another turtle object. So that's a turtle object. This turtle object has its own X variable, okay? And the x variable in here starts, well, he started, let's see, where's the turtle? Bring him up. When he started, his x variable is 0, and his x variable still is 0. When he started, his y variable was 0, but now I've made it 50. So right now the y variable has been updated to 50, and his heading is still north, so his heading is still 0. Okay, and then this turtle reference variable refers to that turtle. Okay. Okay. Now, try this. Okay. Let's see what this line, what this piece of code will do. So notice I'm just typing new turtle. I've got a new turtle. Can I make this turtle move forward? Here's the question for you. How would I make this turtle move forward? Anybody want to guess? How might I, can't you think there's a way for me to make this turtle turn right, turn left, or move forward? In the picture over here, we've got a turtle object. So we've created a turtle object. This is our third turtle. That turtle, so that's a turtle object. Okay, and it's got data in it. That turtle is, see, it's sitting at the origin. So that turtle has got his x equal 0, and his y is equal to 0, and his heading is north, so 0 degrees from north. Okay, can I make him move forward? I need to send a forward command to him, but we send the forward command to a name. See, we use the name to send the command. Notice how this said, no name turtle. Okay? It's a no name turtle. Okay, it's actually a no name turtle. We don't have a reference variable that turtle. So the answer is we can't send anything to that turtle. That turtle is just going to sit there. We have no way of making the green turtle move because we don't have a reference variable for it. Okay, and there's no way to attach a reference variable. Java doesn't have a way to attach a reference variable to something you created and didn't give a name to. We created the object, didn't give it a name, and Java has no way for us to go back and give it a name. So that turtle is stuck in that position forever now. That turtle's just sitting there with that data in it, and we can't call methods on that turtle and make any changes to it. Okay. Now let me do another thing. Let me say T3 equals T2. Okay. So I'm using these two variables. I'm saying T3 equals T2. Notice that that's a lot like over here when I said that T2 equals T1. Okay. That took this arrow and put it into there. It took the arrow from T1 and put it in T2. So this is going to take the arrow from T2 and put it in T3. That's going to take this arrow and put it in here. What that's going to do is it's going to replace this arrow here. So I'm going to go over here and I do this. I won't see any change in the picture. Okay. Okay. But over here in this picture, what I've done is erase this arrow. I've erased this arrow. Oops. And I've replaced it with an arrow that points over here. Because I copied what T2 refers to into T3. That means I've lost any way to send messages, call methods on this turtle. I can't move this turtle anymore. Now all my names point to this turtle here. So if I go now, whoops, all my names point to the purple turtle. That was the first one we created. That's the purple turtle. Oh, one of the things that's in here is the color of the turtle. So you can, a turtle remembers its color. So this turtle would have one of the pieces of data inside this turtle would be what its color is. This is the purple turtle. This is the green. This is the green. This is the gray turtle. No, I'm sorry. This is the purple turtle. This is the purple turtle, the gray turtle, and the green turtle. Okay, the purple one, the gray one, and the green one. We only have access now to the purple turtle. So for example, I go down here, I say T3 dot forward. It's the purple turtle that I'm talking to now. Okay. So I sent a message to T3 and it moved the purple turtle. Before it was moving the gray turtle. Okay. So how do I understand that? By my picture. If I know what every one of these things does in my picture, I know that what I did there was when I did that line, I erased the turtle arrow that was in here, the reference arrow from this turtle to from this turtle variable to this turtle object, and I replaced it with an arrow from this turtle variable to that turtle object. So now all of the variable names are sending commands to that turtle. This turtle now has lost a name, and it's just like the other turtle. We can't do anything with it anymore. We can't send commands anymore to this turtle or to that turtle. So right now, the gray turtle and the green turtle are just sitting there. They're going to sit there for as long as this window's up. We can't send commands to them. There's actually no way in Java to recover a name to an object that's lost any name. Once an object is lost, actually we have a word for it. This becomes a garbage object. This object is referred to as a garbage object. It has no name, so we can't use it anymore. And this is a garbage object. It has no name, so we can't use it anymore. Okay. So the effect of the object is still in this picture, but we can't work with those objects anymore. And we got 3 names for that same turtle over here. Okay, so we have three reference variables pointing to that same turtle. Now, if I want, I could go over here and create another world object. Okay, I'll create a world reference variable. Okay, so I'm going to create a world reference variable. Okay, and it's a world reference variable. I'm going to call it W2. Okay, and I'm going to create a new world object to go with it. Now, I could make that world reference variable point to that world object, but that's not very useful. So I'll make this world reference variable point to a new world. And I'll make it a small world, 100, 100. Okay, so I'll make it a small world. No, actually, that one was 300. No, that's too small. So I'll make it 200 by 200. Okay. Okay. See, he appeared behind one of our windows. So there's a world and there's another world. So I've got 2 world objects. Don't have any turtles yet in this world object. I can't move a turtle from one world object to another. There's no way to move a turtle from that world object to that world object. So I have to create new turtles to put them in this other world. Okay, so I'm going to create one more. I'm going to create one more turtle and put them in this world. Okay. Oh, in my picture, I should create another world object. Okay, so I'll create another world object over here. Okay, so this is a world object. Okay, and then this reference variable refers to that world. Okay, and that world is a 200 by 200 world. So it remembers that information. Every time Java wants to draw that world, it needs to know how big it is. If you make a turtle and give it a location that's too big for the world, the turtle will just be off the edge of the world and you won't see it. So the world needs to remember how big it is, so it'll remember when a turtle has gotten to the edge of it. Okay. Okay. So I've got the two world objects. I've got two world reference variables. I'm going to create another turtle. I'll create a turtle reference variable T4. It's my fourth reference variable. And then I'm going to create a turtle object, and I'm going to put him in world 2. Okay, so there's that. Now over here in the picture, there is, this is why the Java visualizer is nice. Instead of having to keep updating a picture, it does it for you automatically. So, but it's good practice for us to think this way. That's a turtle variable called T4. So I've got 1, 2, 3, 4 turtle variables. Okay. I'll put this turtle object in my picture, say right there. Doesn't matter where they go in the picture. Just there's a turtle object. So that's a turtle object. And it starts off with, in its world, x equals 0, y equals 0, and the heading is heading north. Okay. And this reference variable points at that turtle. Okay, so that's what our picture looks like now. So when we use T4, we can send messages to that turtle. Now, if I'd like that turtle to have two names, this turtle's got 3 names. This turtle's got 1 name. Let's give there's 4 names altogether. Let's give this turtle another name. So I'm going to go ahead and take name T3. I'm going to make T3 another name for T4. Okay. Not sure why they gave that answer there. Okay, now this one's T4 and it should also be T3. So T4 dot forward. Okay, notice they almost went off the edge of the screen. Okay, and then I'll say T3 dot turn right. And I'll make them turn right again. And I'll make them move forward again. Okay. Notice that T3 and T4 are both names for that turtle. Okay. So, oh, and then if I update my picture, I've made T3, he's no longer a name for that turtle. T3 is now naming that turtle. So I update my picture. Okay. This turtle's got 2 names. This turtle's got 2 names. And we've got 2 turtles with no name. They're just kind of lost to us. There's 2 turtles over here that are lost to us because they don't have any names left. Okay. Notice the picture starts getting messy, but programmers have to keep track. These are the kind of things that programmers have to learn to keep track of. Eventually, you keep track of these things in your own head. Like there's not that much here. There's 4 turtle variables and 2 worlds and 4 turtle objects and 2 world objects. Okay. And after a while, you start getting very used to be able to keep track of this stuff in your head. But it's also, especially when we do more tricky coding in more advanced classes, these pictures can help a lot. These pictures can make all the difference in the world in understanding how programs work. When people sit down and write very complicated programs, it's real common to draw pictures to help understand the programs. Programmers have lots of different diagramming tools and different ways of drawing pictures to help them understand code. So this is what we call a memory diagram. And in one of the textbooks, there's a section on memory diagrams. If we go back to I think it was in chapter 2. Let's see. I remember think it was chapter, no, let's see. Yeah, it's not this, so I think it's chapter 2. See, memory diagrams. Okay, they talk about how you can draw pictures. Okay, so memory diagram, drawing, we think we're drawing a picture of what's in the computer's memory. The computer's memory are its variables. That's what the computer remembers. So the computer, this picture we've drawn, this is what we think of as the computer's memory. And it has the frames and the objects. Okay, the frame are the variables and objects are the, there's the variables and the objects. Okay, in the Java visualizer, the variables are over here on the left under frame, and the objects are over here on the right under objects. Okay, so that's what we think of as in computer's memory when it's running the Java program. The program is literally keeping track of these variables and using the variables to update the data in the objects. This is why it's called object-oriented programming. You use variables to keep track of objects, and when you call methods on the variables, you're updating the data in the objects. So you write your programs by calling methods on objects using their names. Okay. You can give any given object more than one name. Okay. You can have objects with no name, but that's not very useful. An object with no name is kind of useless. So we've got two objects sitting here with no name. They're kind of useless to us. But if you have a name for an object, you can you can call a function, a method on the object, and then the method updates the data in the object. Okay, objects are bundles of data with a name for the bundle. Okay, okay. All right. So that's the key idea in object-oriented programming: is that you're creating objects using the word new. You create variables, and the variables are names for the objects, and then you call methods on the variables using this dot notation. You call methods on the variables using the dot notation. That tells the objects to update themselves. Okay? And in our case, when we update a turtle object, we see a picture of it. This is a graphical. What we're doing here is a graphical Java program. Not all Java programs are graphical, but this one, when you update a turtle object, you change a picture. Okay? In a minute, we'll work with another kind of object, a string object, which are not graphical. There are no, a string doesn't show up until you print it. Okay, whereas turtle's in this window is showing up as a picture here. Every time you call a method on a turtle, this picture updates. We'll see that with strings, you only see the difference in a string if you print it. Okay, so you need to see the things. You want to see the results at some point, but in the case of a string, you won't see the result until you print it. In the case of a turtle, as soon as you as soon as you call a function on a turtle, you see the result. Okay, let's see, I can T1. That's back to this turtle. Dot turn negative 45. T1 dot forward. Let's see. Now, if I send him forward really far distance, just notice, see, he's off the screen. Well, it's kind of, it's once he hits the edge of the screen, all kinds of weird things can happen. Notice he seems to be down here in this corner here. Okay, that's not really obviously why that would happen. When the turtle hits the edge of the screen, strange things can happen. Okay, so he seems to be right now down at that corner. See, he's for some reason he's down there at see, he's turning as I'm making him turn. He's turning. For some reason he's right down here. I'm not sure why. When he goes off the screen, different turtles in lots of people have written the code. Turtle's not part of Java, so this turtle was written by the person who wrote this textbook. This textbook here, the one that had the turtle code in it, this turtle was written by the person who wrote that book, and it's up to them to decide how their turtles act when they go off the screen. Not all turtles act the same way when they go off the screen. So this book wrote this version of the turtle code, and I don't remember how their turtles act when they go off the screen. Some turtles hit the edge and sit there. Some turtles just keep on going. Some turtles, when they hit the edge over here, they'll bounce in, they'll come in like in a Space Invaders game. They go off this edge, they'll come in on this edge. Or if they go off the bottom edge, they'll come in on the top edge. So some hit the edge and just sit there. Some just go and the turtle would be right down here, for example. And others, when the turtle goes out, they come back in somewhere else. I don't know how he ended up in the lower left-hand corner there. Like, I'm not sure what made him appear down here. Okay, usually you keep the turtle inside the window, but everybody who's written a version of the turtle does different things for their turtles when their turtles hit the edge of the window. Okay, all right, now let me save this picture. Okay, I'm gonna just save this picture so I don't lose it. Okay, let's switch gears and start talking about a different kind of object, string objects. Okay, and for string objects, I'll go ahead and go use the Java visualizer, because the Java visualizer will draw pictures of string objects. So I'm going to go over here. Okay. And I'm going to string S1. So there's a string variable. If I just do that and visualize it, there's not much to show. See, it didn't even show anything because I didn't even give that string a value. I didn't even give it a value, so it doesn't even show the variable. If I go here and give it a special value called null, that means that string variable doesn't refer to any object. Okay, so now go over here. See, S1 null, there's no object yet. This is a special value you can give a variable. Like I could have done that over here too. I could have created a turtle over here. I could say turtle T6 equals null. I'm creating a turtle variable, but not putting anything in it. So that does not represent a turtle in my picture because I haven't created a turtle object. So there's no turtle in the world or anything like that. Okay, so I just created a turtle variable and said, okay, for now, that turtle variable is not a name for any specific turtle. Okay, in Java Visualizer, just shown here is null. Okay, the turtle, this string variable doesn't point at any object. Okay, now go back here, change it to a string. Okay, and I need to check this checkbox. I want it to show the arrow. Oh, it bogged down. I'm going to copy my code. Oh, it finally came back. Okay, it finally came back. Let's try it again now. There, see, this time worked. Now I'm going to get a picture like we did before. See, there's the reference variable referring to an object. Now, string objects, the data they hold is exactly those letters. Now, remember, in our picture over here, we said, what's the data that a turtle holds? A turtle object, well, world object remembers its size. A turtle object remembers where its X and Y and location is and what its heading is. Okay, so the turtle remembers where it is. The world remembers how big it is. A string object, what sits inside of it are the letters of the string. That's its data. Okay, so the string remembers what letters it holds. Okay, I could do something like I did with the turtle. I can create a string variable S2 and copy S1 into it. So now I'm going to have two string variables, but only one string object. Okay? Two string variables referring to one object. Okay? Now, here's an example of a message of a function I can call in a string. I can say string1 dot to uppercase. Now, what that's supposed to do is change all the letters in the string to uppercase. And if I go here and visualize this, okay, create one string, create a string object with a string reference variable. That's line 4. Line 5 creates another reference variable to the string object. Line 6 didn't do anything. I said to the letter, become all capitals, to uppercase. What happened there? Well, okay, let's go back and change this. Well, actually, strings are kind of funny. When you tell a string to do something, it does not change itself. It makes a copy of itself. So what this did was it created another string object that held the letters capital H, capital E, capital L, capital L, capital O. But I didn't give a name to that object, so I lost it. Just like over here, if we lose the name to a turtle, we lose all access to it. Or if over here, we actually created a turtle with no name at one point. We created a no-name turtle here, and the turtle appeared, and then we had no access to it. Over here, we've created a no-name string. We told this string to uppercase itself. And what a string does is it doesn't change its data inside of itself. It makes a copy of itself with the new letters in it. So what I need to do here is I need to do the following. String S3 equals, now this will become a name for that new object that is HELLO capitalized. So when I call a method on a string, unlike a turtle, turtles modify themselves. When you tell a turtle to move forward, the turtle changes the data in himself. Strings never modify themselves. When you tell a string to do something, it makes a copy of itself, and the change happens in the copy. See? So that line of code said S1 to uppercase yourself. Well, what S1 does is say, okay, I'm going to make a copy of myself, and I'm going to put the letters HELLO in the copy, but in uppercase. Then this says make S3 a name for that copy of HELLO. Okay. I can go down here and say S2 equals S3 dot to lower case. Okay. Let's see. Let's see. Well, let's do a different example. I can take substrings of strings. A substring means a part of a string. I want the part of the string that goes from what we're going to, okay. Let me show you something about strings. It's real important. We're going to need this. Let me open a text window. Okay. Here's a string, HELLO. Every letter in the string has associated to it by Java a number, what we call the index. The H is letter 0, E is letter 1, L is letter 2, the other letter is letter 3, and then the last O is letter 4. These are called the indexes of the letters, okay? That lets you give essentially it becomes like a name for each letter. So this L is letter with index 2. Now notice the indexes start with 0. That's kind of a tricky thing. The indexes start with 0. I can create a substring of this string, like the ELL. The ELL would go from index 1 to index 3. So over here, what I'm going to do, so I'm going to say I want a substring of hello from index 1. Now, if I want to go up to index 3, the way this command works is I go up to 4. I say start here and give me all the letters up to but not including that one. So that's going to give me letters 1, 2, 3, which is the ELL. Okay. Now, all methods on a string return a copy of the string. They don't change. This S3 is not going to get changed. It'll still be, actually S3 is the S3 is HELLO, okay? And it's got indexes 0, 1, 2, 3, 4, okay? So S3 actually is the uppercase one. So this is going to give me the ELL in uppercase, okay? But it's not going to change S3. It's not going to change HELLO. It's going to give me a new string, okay? So, and then it's going to make my old name, which was another name for this guy, a name for this new string. So I have this string here. Then I have the capitalized version. That's my second string. And this will give me my third string. And I'll make this name a name for that third string. Okay, so now watch my code run. Now, this is where pictures help us think about code. The first line of code creates that variable, and that's referring to that object. The second line of code creates a second name for that same object. The third line of code creates a copy of that object holding all the capital letters and makes S3 a name for it. Now this line is going to make this S2 a name for a new string that's going to be the part of S3 that goes from letter 1, which is the E, capital E, up to but not including the capital O. Okay, so see how S2 switched from being up pointing to that guy to being pointing to this guy. Okay, so we can understand Java code by drawing these pictures. Notice that that picture is, see how it's like this picture we drew. We got the frame on the left, which holds the variables. And then on the right, we have all the objects. The more objects you have, they just start filling up over here. The Java visualizer will just put the objects wherever it can, tries to fit them over here, and it gives you arrows, tells you which variable refers to which object. And a variable can bounce around pointing to different objects. Now, over here, suppose I lose, let me point S1 at the capitalized one. Okay, so I'm going to copy this arrow into this one. So I'm going to copy into S1, I'm going to copy S3. Okay. Okay, into S1, I'm going to copy S3. Okay, let's go step through the code. Okay, now we're at this point. Okay, this one points to that, this one points to that one, this one points to this one. Now I'm going to say copy S3's arrow into S1. So that'll make this one point to here. What's going to happen to this string? In this Java visualizer, when that string loses an arrow to it, it'll disappear. See, it disappeared. And the other string's kind of moved up. Okay, go back. See, that string, the lowercase HELLO, when this arrow got copied down to this capital HELLO, this guy picked up 2 arrows. This guy lost any arrows, and he disappears. Now, in this picture over here, we really should have made the turtles with no arrows pointing to them disappear. They would still show up in this picture, but they actually disappear from Java's memory. When an object has no arrow pointing to it, it actually disappears. It gets what we call garbage collected. Remember we said that these are referred to as garbage objects. When an object has no arrow pointing at it. It's a garbage object. It's actually garbage collected, which means it disappears from memory. Java cleans up its memory. They use kind of vivid terminology. Objects with no arrow to them are garbage objects. Java cleans up memory by garbage collecting the garbage objects, and they're cleaned out of memory. Okay, so that it doesn't show up in the picture anymore. And over here, a lot of people would say, "Oh, you should have erased that turtle from the picture because there's same with this one. This one should have been erased from the picture because there's no reference variable to it." Okay, but it's also kind of nice sometimes when we draw these pictures to leave that to remember that that turtle object was created, and then this one was created and had an arrow to it. This one was created without any arrow to it. Those turtles do show up in this picture, but that's why you can't go back and somehow access those turtles because they're actually gone from memory. That's why I said that Java has no way to give you access to a turtle that's lost all its arrows because the turtle is actually deleted from memory. It doesn't get erased from this picture over here, but it does get deleted from Java's memory. Okay. Okay. So we can do memory diagrams of these kinds of objects also. So, the visualizer will draw us the memory diagrams for simple string programs. We have to draw the memory diagrams if we want to do memory diagrams for turtles. Okay. Now, one thing that's interesting is what are all the methods I can call on a string? What are all the methods I can call on a string? What are all the methods I can call on a turtle? Okay. That's something that gets documented. That's an important question. Like, what are all the things you can do with a turtle? Once you've created a reference to a turtle, what methods can you call on the turtle? Okay. Now, in this book that does the turtles, if you go to this section, okay, this is chapter 2, section 2.4, calling method. No, I think it's this section 2.3, calling object methods. I think it's this one. No, it's the other one. Section calling methods with parameters. Here's a list of the methods you can call on a turtle. They think of a turtle as holding, this is the data that a turtle would hold. See, some over here, we talked about how a turtle would hold data, his X coordinate, his Y coordinate, and his heading. Well, here he called it X position, Y position, and he didn't put the heading in here. There's the color of the turtle. You can change the size of a turtle if you want. You can make your turtles grow and shrink. You can make these turtle pictures grow and shrink. So you can control the size of a turtle. And here's the methods you can call on a turtle. For example, you can tell a turtle to raise his pen. If you tell a turtle to raise his pen, let's go back over here. Okay. Actually, I'll use the other turtle world. Okay. This is turtle. That's turtle, I think. Does anybody remember? This was turtle. Well, our picture should tell us. So that should be turtle T3 or T4, I believe. Okay. So we just check. T3, whoops. My thing is not liking me typing. T3, forward. Okay, that's him. Okay. Then T3 dot turn 180 degrees. Make him turn around. Okay. Now I'm going to tell him to raise his pen. Let's see. I'm going to turn right. Make him move forward a little bit. 50. Make them move forward a little bit. Okay. Make him turn left. So he's headed up. Oh, misspelled it. Misspelled it again. Okay, now he's heading up. But I'm going to make him raise his pen. So I'm going to say T3 dot pen up. Okay. Now if I make him move forward, he's supposed to, you think of him as having a pen in his belly. So when he moves, the pen is drawing. If you tell him to raise his pen, the pen is no longer touching the ground. So if he moves forward now, see, he didn't draw anything. So I raised his pen, so he didn't draw while he was moving. Now I can say pen down. And then if he goes forward again, now he's drawing. Okay. Now, the idea is that over here is the explanation of what I can tell a turtle to do. I can actually make him go backwards. Besides from going forwards, there's a backwards. Turn left, turn right, raise and lower his pen. You can tell him to go forward by a certain distance. Notice if you go forward without any parameter, I think it's 100 steps. Or you can tell him to go forward by a fixed number of steps. Same with backwards. You can turn in a degree. You can turn left and turn right. Turn left is 9 degrees counterclockwise. Turn right is 9 degrees clockwise. This is turn however many degrees you want. Positive is clockwise, negative is counterclockwise. You can also just jump him to an XY coordinate. This is just teleporting. Just tell the turtle to move from there, from wherever he is to that X and that Y. You can tell the turtle to change his color and things like that. So there's a list of all the things you can tell a turtle to do. Similarly with strings, there's a list of all the things you can tell a string to do. But now the string list is really long. We'll learn about it as we go along. I'll give you a list of methods that you can tell a string to do, because the true list is about 150 methods. There's about 150 different things you can tell a string to do. We're only going to need about 10 of them for doing homework assignments and practicing. So I'll give you a list of the things that you can tell a string to do. And then that list, the ones that we're going to be using mostly are, let's see. Oh, right. We're going to be using the 2 uppercase, 2 lowercase. These are the ones we'll use the most. 2 uppercase, 2 lowercase, substring. You can ask a string how long it is. So you can ask the string, tell you how many letters are in the string. You can ask a string, where do you have, there's something called the index of. We'll see, it's really useful. That lets you say, where in the string is the letter G? And it'll return you the number of the index of the letter G, if it's in the string. If it's not in the string, it gives you back the number -1, which is a way for you to say, oh, there's no index -1, so that means the G wasn't in the string. So there's going to be a whole bunch of methods that we can call on strings. Okay, 2 uppercase doesn't take any parameters. 2 lowercase doesn't take any parameters. Substring, you give it 2 parameters, the start and the stop, like 2 to 5. Where to start the substring and where to stop the substring. Length doesn't need any parameters. And index of, you tell it what letter to look for. Actually, you can even tell it to look for a substring. You can say, where is the word dog in my string? Okay, so if I have a string and I want to know if the word dog appears, the letters D-O-G in that order appear in the string, I can say, what's the index of dog? So we'll see there's going to be a whole bunch of methods that we can call on strings. Okay, and that's what object-oriented programming is about. Having variables to point to objects and then calling methods on those objects to do work for you. Okay, so we'll see how we can solve problems involving strings by calling methods on string objects, and we can solve all kinds of nice problems on strings using the methods that are in the string objects. Okay, so we run out of time, okay, and uh, read the last two sections of this chapter on methods and objects. Okay, and on Wednesday we'll do some more, especially strings. We want to learn all the important methods that are in strings. So we'll do more examples where we'll see what are the other methods in strings that we want to know about. And I'll give you a little list of the methods and strings that we're going to use. And like your next homework assignment when it comes out will be mostly a homework assignment for you practicing using solving problems using string methods. Okay, so read the last sections on string on well turtles and strings and methods, and do these practice problems. And we'll do more of these string method stuff on Thursday. Anybody got a last second question before we leave? Any last second question at all? Okay, I have office hours this afternoon. If you have questions about the homework assignment or questions about anything we're doing, you can come to the office hour. Otherwise, send me email messages. Okay, so I'll go ahead and I'll put this picture that we drew up on the course website. So if you you should review these ideas. I'll put this picture that we drew here. Okay, and I can, along with that picture, I'll put this list of commands we typed. So you can. The idea is that you could look at this list of commands, and you should see remind yourself how this list of commands created this picture, how we updated this picture as we did these commands, because that's what programmers need to do. Programmers need to understand the connection between the code and what it does. And for in you know and what it does is, in our case with the turtle, it draws these pictures, but it also updates memory. So there's code, memory, and the output. And programmers have to keep all these connected together. What's the code? What's the picture look like in Java's memory? What is the output we're seeing? So I'll put copies of these up on the website so you can think about them, because this is what you have to practice with. Okay, so I'll quit here. Anybody, any last second question? Okay, so we'll meet again on Thursday, and let me know if you have questions by saying email. Okay, so bye. See you Thursday. Bye.